Good evening everyone, myself Gautam Sharma. I welcome you all in a second part of the video. Okay, so today I am going to teach you about a system of particle and rotational motion part 2, where I will discuss about the motion of a center of mass. As we have discussed about the center of mass, how to find the position of the center of mass. Now today I am going to discuss about the motion of the center of mass, what actually motion of the center of mass happens. Okay, so as we know that position of the center of mass can be written as position of the center of mass can be written as RCM and RCM, this is equal to M1 R1 plus M2 R2 plus M3 R2 dot Mn Rn divided by M1 plus M2 plus M3 dot. So as I have discussed earlier, now this is your total mass, right? M1 plus M2 M3 total mass of the system. So can we write here this M into RCM, and this is equal to M1 R1 plus M2 R2 plus M dot Mn Rn. Now we will differentiate this whole equation with respect to t. So if I will differentiate with respect to t, as m is constant, so can we define as dr by dt, this is equal to m1 dr1 by dt plus m2 dr2 by dt plus dot mn drn by dt. Now the rate of change of position is velocity. We know that velocity is what? Velocity is dr by dt. So here, from here, dr by dt can be written as the velocity of center of mass, because r is also center of mass only. So differentiation of position of center of mass with respect to time is known as velocity of center of mass. So can we write here m into vcm, and this is equal to m1 dr1 by dt is equal to v1, dr2 by dt is equal to v2. So whatever I have just differentiated whole equation with respect to t. So I am getting here m into velocity of center of mass is equal to m1 v1 plus m2 v2 dot mn for n number of particle. So finally velocity of center of mass can be written like this. Okay, velocity of center of mass can be written like this. So m1 v1 plus m2 v2 plus dot mn vn divided by n. In this way we can find the velocity of center of mass, right? Now if we need an acceleration of a center of mass, so how you will find? So again the same equation, above equation, differentiate it with respect to time t. So what we will get? M d velocity of center of mass with dt is equal to m1 dv1 by d2 dv2 by dt2 m2 dot mn dvn by dt. Here what I have done, again velocity, we have differentiated velocity, part velocity. So we have what we will get? So here what we are getting, we have differentiated it with respect to time. So when we differentiate velocity with respect to time, so we will get acceleration center of mass, acceleration of center of mass. So finally we will get acceleration of center of mass similarly to the above equation, m1 a1 plus m2 a2 dot man divided by m. So in this way we have got the acceleration of center of mass. Now the center of mass of a system of a particle moves as if all the mass of the system was concentrated at the center of the mass and all the external force were applied at that point. So whenever an object is being moved, so center of mass will move in such a way that it will be appear like that force is being applied at the center of mass and it is moved. A whole object this center of mass is moving. For example, a parabolic path of the projectile motion. So when this is the center of mass of the fragment of the projectile continues along the same parabolic path which would have followed the if there would be no explosion. See, as you know that previously a body is moving like this and suddenly it explode at this point. So we know that exploded part will be follow different part, but the center of mass of these both will follow the same path only. Earlier it was moving and expected to move in this direction. So as a rules what will happen, it will move in such a way that it appears that center of mass will move in this direction. So okay, now now I will discuss about the linear momentum of the system of particle. What is linear momentum of the particle is defined as we know that linear momentum is equal to p is equal to mass into velocity, that is it is our mass and it is our velocity. So as per Newton's law, what will happen, force is what, rate of change of momentum, rate of change of momentum. Okay, and as we know that mass into velocity of center of mass is equal to m1 d1 plus m2 p2 dot dot dot. So this is the equation. So can we write here momentum of the center of mass, momentum of center of mass can be written as mi vi summation from I to n, that is m into velocity of the center of mass. Now differentiate it with both the side with respect to time t. So when we differentiate momentum with respect to time t, what will happen? dp by dt is equal to m vc, center velocity of center of mass, divided by tt. So mass into acceleration of center of mass, and if it is your mass into acceleration of center of mass, it means that mass into acceleration is your external force. So external force as per the Newton's second law. As per Newton's second law, rate of change of momentum is equal to external force applied on it. So this is hence proved. Okay. So if external force is zero, then what will happen? If external force, if F external is zero, so what will happen? Then P of the center of mass will remain constant. Why? See here. If external force is 0 means what? dp by dt is equal to 0. It means that p will remain constant. It means that the momentum is also constant. Momentum is constant. So from here what we infer? We infer that if no external force in a system of particle is acting, then the momentum of the particle will remain conserved. Okay, there will be no change in momentum. I hope you have understood now. Right? As we have seen that momentum will remain conserved, so p of the center of mass will remain unchanged. It will remain unchanged. Since mass will not change, so the velocity will also not change. So if mass is constant, so mass of the system, see, in case of braking also, if there is 1 kg and it is split into 1 and a half kg and a half kg of the mass, so what will happen? Total system mass will remain constant. I am talking about system. I am not talking about the single. If it breaks into two parts, then two parts will be different. I am talking about the single entity of the system. After breaking also, both the mass will remain in the system. Okay. So as linear momentum of the system will conserved, remain conserved. So velocity of the particle will not change. Okay. So see, from here you can understand the example. Suppose this is your nucleus, and when it moves from here, so what happens? This element Ra is break into two parts, Rn and helium. Okay. See, initially center of mass was moving in this direction. So after breakage also, center of mass will remain in this path. In spite of being split into different parts, it is since heavier and it is lighter, center of mass will move. This body will move in such a way that the center of mass of these two body will remain in the same constant part. Why so? Because there is no external force. External force is zero, so it means that momentum will remain constant. Okay, and if momentum will remain constant, it means that the momentum in center of mass will not change the path. Okay, again I will give you one more example from there. Here you can get clear. See here, see an object 1 and object 2 are spinning. Okay, spinning, understood, but in both are spinning in such a way that the center of mass will remain constant in spite if there is no external force. So definitely center of mass will remain constant. So this is what all about the motion of the system of a particle. Now there is one more topic, that is vector of product. So vector of a vector product over two vectors. So let us consider this is A and this is your B. So what will be the vector product? So vector product means cross product. So that is equal to A cross B, and this is equal to magnitude of A into magnitude of B into sine theta. So this is the vector product. Okay, sine theta into n cap. So the main thing is that what is the direction of a n cap? So n cap will always remain perpendicular to the A cross B. So see here, suppose this is your n cap. So n is your perpendicular to A vector as well as B vector, and it will keep the direction in such a way that you have to use right hand rule. You have to use right hand thumb rule. So if I will use right hand thumb rule, and if you place all the finger toward A and we will cross B, then the thumb will give the direction of the vector. So for example, if you are talking about screw, so screw, what will happen if you will rotate in clockwise direction, anti-clockwise direction, so it will bend up. So this is what right hand screw rule is about. So vector product is very important, but I have already discussed more details in the separate video. You can refer that video so that you will able to understand the vector product. So I won't discuss more. So I hope you have understood about the motion of the system of particle. Thank you. That's it for today's video.